So let's look at a molecule to see how formal charge is established and how you can reduce the formal charge. So here's sulfur dioxide, and if we went through the steps for the Lewis structure, this is what we would get for sulfur dioxide. And let's apply the formal charges. If we look at the double bonded oxygen, we know that that's 0, according to our previous calculations, but shown here. And then if we look at the other oxygen, this is a -1. Basically, one bond plus the 6 unshared electrons has an overall formal charge of -1, which means it kind of has an extra electron it didn't start off with from its valence electrons. And then looking at the sulfur in the middle, it has a +1 charge, which shows it's kind of missing one from its original valence electrons. So we have non-zero numbers, and they all add up to 0 because sulfur dioxide is a neutral compound. How can we make the formal charges of sulfur and oxygen 0 if possible? So let's think about using double bonds to make formal charge as close to 0. So remember, this oxygen has a double bond and two pairs of electrons, and so that has a formal charge of 0. If we do the same thing and make this pair of electrons share more to become a double bond there, then we can also do that, and we'll see what happens to the sulfur. So those two oxygens are now 0, and the sulfur in the middle is now 0, as it now has the same number of valence electrons in its sharing position as it started out with. So this is a good way to think about minimizing the formal charge to get as close to 0 as possible when you're doing the Lewis structure if you end up with non-zero formal charges. In some cases you can't help having non-zero formal charges for elements, but if possible we'll try to look at reducing. And remember, we can violate the octet rule for third period elements and above because they have those empty orbitals, but if this was like a nitrogen or a carbon, we couldn't put like 2 double bonds in a lone pair there. So remember, don't violate the octet rule unless you are able to with those upper elements, those third period or higher elements.